Okay, so this is Mrs. Black. Let's pretend you're pushing a chair, a 20 kilogram chair, at an angle of 30 degrees with the horizontal. Alright, so the force that you're pushing it with is 60 newtons. So then you can see 60 newtons there in the blue pushing down on the chair at an angle of 30 degrees. Alright, so this is what you would be looking at. Okay, so first of all, let's look at what forces are acting on this. Okay, as you can see, the forces acting on this are the normal force on the chair from the floor, that's upward there, the downward at an angle push from the person, the human on the chair, and then the gravitational force downwards on the chair from the earth, and then the friction force on the chair from the floor. Alright, now you can calculate the gravitational force by multiplying the 20 kilograms times 10 newtons per kilogram, and that would get you 200 newtons. Alright, so you can go ahead and label the gravitational force 200 newtons. And then you break the pushing force into, as you can see the pink there, into its y and x components. And you can see that that's a 30 degrees from the horizontal. And so the y would have a ratio of 1. The push would have a ratio of 2. And then the x would have a ratio of square root of 3. And those are what you're going to use to find the normal force and the frictional force. Alright, so then, okay, if we look here, breaking down the push, the 60 Newton push, into its y and x components. So y is to 1 as 60 newtons is to 2. That would make y 30 newtons. And then x is to square root of 3 as 60 newtons is 2. So that would make x equal to square root of 3 times 30 newtons. And you calculate that out, and when you round it, it's 52 newtons. So we have 52 newtons for x and 30 newtons for y. Okay, now we look back at the diagram again. And the push is still 30 or 60 newtons. The gravitational force is still 200 newtons. But now if you look at x and the friction force is going to be equal to x. We've already calculated x as 52 newtons, so the friction force is 52 newtons, so you can label that. And then if we look at the normal force, it's the same as the gravitational force plus the y. So we already calculated the gravitational force, we already calculated y as 30 newtons, so we add the 200 newtons gravitational to the 30 newtons of y, and we get 230. I know that kind of looks like a 231, but it's 230 newtons. And so then you can label the normal force 230 newtons. Now, it may seem strange to you that the gravitational force is less than the normal force, but think again about what was happening. You were pushing down at an angle, and so not a lot more, 30 newtons more in fact, force was being pushed into the ground because you were pushing down. So part of your push was going down and part of it was going sideways. And so, there you go.